Hi, this is my video of my 3D printed throttle quadrant. It's a modular system, plugs into the PC, and you can have throttles, flaps, elevator trim, landing gear, anything you like. And it uses an Arduino to connect to the PC, which with the help of the joystick library means that the device is seen as a game controller, and it can therefore be configured to any controls you like within the flight simulator software. The trim wheel has two complete rotations in each direction, so four rotations end to end. So here we have the parts that are ready to be assembled into a Quadrant module. There aren't that many parts, and there's only actually one moving part, so it's fairly straightforward. There's the case, the right and the left case sides. There's the pot holder and the pot, some hardware, 3 parts for the lever itself, and what I call the friction plate. So let's assemble. The first thing to do is to assemble the lever, because that needs to be glued together. So we're going to just use super glue. These are 3D printed out of ABS. So we're just going to glue these bits together. So the first 2 parts of these two go together, and they need to be glued together so that the sticky up bits are both sticking up on the same side. And then the knob, there's 5 different knobs available, different shapes and sizes, and they all fit the lever, so they just go on the end, and that's what one of them will look like at the end. So we're just going to glue that one together. Super glue is nearly empty, so the glue obviously lasts longer than the bottle, and the top's stuck on, so we just use a cocktail stick just to get the glue out of the bottle. A little bit of glue in the recess in the end of this part. Glue the bottom end on. Just and then glue the knob on the top. You can obviously paint these before you assemble it. Might be a bit easier. So that goes on the end there like that. Right, put that to one side, just to let the glue go off, and put the top back on so we don't want to spill that. And now we need to fit the pot into the pot holder. So the details of the potentiometer used are on the web. If you look at the link in the description of this video, that will take you to the details of what all the parts are. So the important thing about this pot is there's a little lug, and that fits into a little hole on the 3D print. It's a snug fit because I don't want it moving once it's in there, so it's a fairly snug fit, so it can take us a little bit of wiggling to get it in, but that's the best way of doing it. And just take the nut and the washer off, fit it into the holder, line it up, just line it up there, and in it goes. There you go. Yeah. So that just sits in there. put the washer and the nut back on. Doesn't need to be very tight, we just nip it up with a spanner just to finish it off there. Good. And now we need to centre the pot, so it's that's going to be about the middle, and now we can just slide the lever on top. So the lever there is all done, ready, all dry, so that can go on top. So the pins on the pot are pointing up the lever, and that's it. It's just a push fit. And that's its full range of movement. We're only actually using 90 degrees of that movement. So this fits into the right hand side, and there's three recesses in there where it fits in. No need to glue it in because the other side holds it together when it's bolted together, and that's the lever action. So we get the other side, put it on top, so that the lever locates through that hole and it's nice and secure in the base. Now to get the friction plate in, we just need to loosen that off a little bit to give it a little bit of wiggle room. Put the friction plate in this half, it slides in. There are 3 different friction plates available, slightly different, and I'm using the middle one here because I find that works best. And then you just put that on and it snaps over the lever, and that friction plate just rubs on the bottom of the lever and gives it that little tiny bit of friction so that it stays where it's put. And now we've just got 3 nuts and bolts and washers. So these are M3, these are actually 10mm M3s. They're probably a little bit short, could probably do with sort of 15, but they do work. And then it's quite a tight spot to get a nut on, but it does go on in the end, he says, eventually. In there, good. So there's three nuts and bolts that hold them together, and when you have more than one module, they're held together just with 2 of the same M3 nuts, bolts and washers to hold each of them together. And then there's the end caps as well, and they're again held on with 2 M3 nuts, bolts and washers. Right then. So obviously just nip those up a bit later. They don't need to be very tight at all. So I just used the end of the screwdriver. Not even going to put it in the handle. Just a little tiny nip, just to keep it together for now. Because it's got to come apart for painting anyway. So this is just for this video. Right, and there it is done. So the bottom of this lever has two detents in it that just locate the top and the bottom, and there are various numbers available. So for flaps you can have different 3 stages of flap or 5 stages of flap. You've got different levers for that with different numbers of detents in the bottom. So now we're going to just wire it up. Very simple. There's 3 wires. The middle wire on the pot is the wiper, which is the one that you need to connect to the analog pin on the Arduino, and the other 2 are positive and negative, and it really doesn't matter which way around they go, as when you plug it into the flight sim you can reverse the axis anyway, so it doesn't matter which way around you put them. So I've got 3 jumper wires we're going to use for this, because I'm going to plug them into a breadboard. So just cut one end off. And then I'll just strip the ends. Tin the ends of these. Just tin the ends of the contacts on there. You can of course put the wires on before you assemble the thing. That might have been easier, but hindsight's a lovely thing. It's not too difficult. There's only 3 wires. Right, that's that done. So now the wires go out the hole in the back. So the hole's big enough just to feed them through. And there we go. So that's that module assembled, ready to plug in. So now here we are in the Arduino software. We've already got 3 pots plugged in. So this is the 4th one, which is on analog pin 3. And the first thing to do is to tell this bit of software that it's being used, and we do that by changing the value in the variable A3 used, and we're then going to change the setting value to 3, and that means that it will output that to the serial monitor. So we just change the variable there to true, change the setting to 3 and upload it to the Arduino. Then we open up the serial monitor and that gives us a value off that pin. So what we need to do is move the lever to both ends of its travel and just make a quick note of the numbers, and they're going to get entered back into this program. So there we've got the top and the bottom values, and then they get entered into number 3. So what happens here is those values are then used in a translation bit of code that translates them into values from 0 to 1023, which are the values that are then sent to the PC, and that's the standard for the joystick library. So just upload that, and now we can see on the serial monitor the right hand number goes from 0 to 1023, so that's the one that's sent to the PC. The left hand one is the pin value. So now we're in the flight simulator software, and we go to options and controls, and then in the Arduino at the top, the Arduino Leonardo, we filter for all items and find the landing gear, and then gear down, and then start scanning. We move the lever down and that finds it, and then validate it, and then gear up, again start scanning, move the lever up and validate it again, apply and save, and now when we move the lever up and down the white box will change in that view. And then finally in the flight sim itself, with the playing with landing gear, we can test it. So gear up, and gear down. So now we're going to assemble a wheel, so a trim wheel, and there's two versions of the actual wheel itself. The first one is the one we're going to use, which is with the separate nodules that go around the outside. So the first thing to do is to grab some glue and glue the little nodules into the outside. So there's 8 nodules, 8 notches. Little dab of super glue and push it in the slot the right way up. One done, 7 to go. What I'm going to do this video in 2 parts. So there'll be the first part, this one, which is gluing the bits together, and then I'm going to paint it before coming back to do the actual assembly of the unit itself. So last one going in. Right, so this is the actual sort of quadrant gear itself, the indicator part, and this little hub needs to go in the middle, and there's a convenient little tab there to locate the two together in the right position. So just a little bit of glue around the inside of there. And slide that hub in the centre. Right, so this is the wheel we've just made, and that centre hub for that fits in there with the key slot that fits in there. And then this is the one piece which has got nodules on it but only on one side, so the back side's flat to make it easily printable. And the same hub fits in the centre there with the key in there. We're not going to use that one though, we're going to use this one. So again, little dab of glue around the inside. Right, I'm going to go and paint these and then come back for part 2. So these are all the parts that we need. So we've got the right hand side, the left hand side with the indicator slot in it, the wheel that we've just made that I've painted, and I've painted one nodule white. I've only painted the outside of it, don't need to paint the middle. Don't want to paint the bits where the gears are, and that's where the key is at 90 degrees to the white painted bit. And then this part I've just painted the bit that's going to show and painted the edge white so it shows against the black background. So we're going to just assemble this. So I've already soldered the wires on this time, and we'll centre the pot and then mount it in with the little tab there. Again, goes in the hole in the 3D print. Again, it's a snug fit, which is good. There it is, and we'll put the washer and nut on. And just nip it up a quarter of a turn just to secure it in there. So just make sure that's nice and centered, and that goes in this part first, and the holes go out, sorry, the wires go out the hole at the back. And again, there's no need to glue this in, it all fits together nicely, so you don't need to actually glue it together. But we are going to grease it up because there's parts in here that the plastic rubs against plastic, so we're going to put some grease on here. So this is grease from a radio controlled car kit that I have built, but any plastic safe grease is good. Put some right on there. This isn't actually located at the moment, we're just positioning it roughly because it's actually located by the bit that goes to the middle of it. And then we've got the cog, and we'll put a little bit of grease on the spindle that the gear goes. And we're lining up the white knob at the end with the two shaft centres. And then that gear should just drop on the top and fit in the centre of the actual wheel. And we're just going to grease the outside of that part so that when it goes in the centre of the other bit there's no friction there. Makes it a nice smooth operation. And I have found it helpful if you just put a little pen mark on the gears where you want them to line up. At the centre of that quadrant, it might be useful just to mark the centre tooth, so that when you line it up you've got a visual guide of where it's meant to go. But it just pushes on the centre, and it's a snug fit, so it does take a little bit of pressure to get it stuck in there. And now when you move the wheel, it's a 16:1 gear ratio, so the indicator moves at a 16:1 to the wheel. Right then, so we're just going to slap a bit more grease in there. Work that in a little bit. Just check it's operating properly. It is, so we can now put the top on. And Yeah, that was the wrong way up, so we'll put it on the right way up. And then again it's just secured with 3 M3 nuts, bolts and washers. And for this one I won't show the Arduino bits, it's exactly the same as doing a straightforward lever, just from one end to the other and put the numbers in. But I will show the flight sim part of this. So that's the wheel now all assembled, all operating correctly. So now in the flight sim I've moved it all to an Arduino Micro, but it works exactly the same, so we're just going to go and filter all, and then we've got to find the right setting for it, which is elevator trim axis -100 to +100. So there are various ones for trim axes from 0 to 100 and things. We want the one that goes from one end to the other. And we'll just go in there, and then you have to wind the wheel a bit until it detects it. Which it has. So then we can just hit validate, and now when we wind the wheel the axis goes up and down. And that's it. And that's my finished unit.